Yeah, let's start off. This was the last one that we did. Let's go ahead with one more problem. We have a rod here. We have a hinge. Rod, mass M, length L. We have a ball of mass M here, which is going with speed U. It goes and collides with the rod. Restitution is Z. And this distance is X. Right? You can neglect all gravity and everything. Find X if the hinge reaction is 0 just after collision. Let's get this. So this particular point, right, there is a name for this thing. This point is called a point of percussion. So there's a particular point on the rod. When you hit there, there'll be no hinge reaction. In cricket, there's a word for this thing. In cricket, this is called the sweet spot on a bat. Did you ever hear the commentary? You know, the batsman, the ball has hit the bat on a sweet spot and the ball is flying and gone to the six. Karke. Aisa commentary aata tha. So there is something called a sweet spot on a bat. So if you can hit the ball at that particular spot, the batsman will not feel any. Just imagine, look at this question. Think of this is a bat. So the batsman is catching here. That's your hinge, right? The ball is coming with a speed of like 140, 150 kilometers per hour, and you're hitting it back to a six. And if the batsman is playing 100, 120 balls, his hands are going to, end of the day will start hurting. But if you can hit the ball at that particular spot every time, right, then your hinge reaction will be zero. That means you're not going to feel anything on your hands. So you can swing your bat with full force without feeling much. So batsmen generally, right, they try to hit the ball at that particular spot. So in cricket, this is called sweet spot. So how do you proceed with this? So there's a particular point on the bat or the rod where if you hit there, the hinge reaction will be zero. How do you handle that? And others do keep your cams on. Mongoose batting tips, even in badminton rackets. Yeah, there anything basically. I just took a rod here. You could, I think cricket is something which you guys remember, so I said took that example. How do we proceed? Think for a minute, then I'll tell you something. Then I'll give you a little more time to try. We'll be wrapping up the chapter today. We'll be starting off fluid mechanics also. So in your classes currently, what is going on? Is fluid mechanics done for everyone here? Or did they start at least? No. Okay, I think People who have two tracks, na, you guys are going in something else. Pace people have not started, I guess. I think after Dharma, they'll be doing fluids only, I suppose. Right, Ishwan? They think after that, what they do? After the rotation thing? Any idea what they do after that? Mostly after that, I think they'll start off with fluid only in one track.
Yeah, but I'm not sure because we don't have the modules for the next part yet.
Okay, Ishwan, check करके बताओ. I think most of you normally na most of you are following NCRT only. Pace people only they're doing something weird. ठीक है अभी क्या कर सकते हैं. Okay. Now you guys are still better. There is one more in the other batch. There is one kid who joined in some other classes. उसका तो work पर energy चल रहा है अभी भी. They didn't do anything till now. NLM, friction, circular motion, work per energy is going on. Nice. And that guy is like, sir, rotation is going tough for me. I said, what is the problem? No, sir, what you're teaching, I'm understanding, but in my classes, they're still teaching work per energy. So I have to do so many different things. I don't know what they're doing there. Time pass kar raha tha. And maybe they'll just rush the portion and finish it off. So you have fluid after thermo and paste. So yeah, ठीक है. मतलब, I think you will catch up in 2-3 weeks. You will catch up. After fluid, we are going to do thermo only. So that way again we will be on track. Hoga 1-2 months there will be a little here and there, but I think after that they will rush ahead anyway. Don't worry. After
For
mostly
us, it
February
was
March,
like
na.
even weirder because our first physics teacher, he rushed through things. So vectors, and he did kinematics ऐसे दो
No,
तीन
no, this is nothing. This is nothing. They'll rush even more. You wait and see. They'll finish. They'll finish all the chapter like the chapter which is supposed to take a week. They'll finish off in 1 or 2 days. So they'll do. Don't worry. Right now, na the teachers are free. Na 12th ka batch chala gaya. When the new 11th batch comes, they will rush the portion like mad. And they will tell you something good. We are finishing all the portion early so that you can revise. Bullshit. This is the reason everyone gives. Big bullshit reason. No one wants to finish off early so that you can revise. They want to finish off early because juniors will come by April. They don't have enough teachers. They have to hire more teachers if they delay your portion. It's a cost saving thing. That's how it works. Anyways, let's see. Now, how to do this thing? So, what are the catch in this question? Think of like this, huh? Forget there is no hinge, okay? So, if there is no hinge and during the collision, if the velocity at the hinge becomes zero, then what will happen? If that point is not even trying to move, and if you put a hinge there, does it matter? It doesn't matter, isn't it? That means then there will be no hinge reaction. So during collision, right, if the velocity of the point which is connected to the hinge, right, has zero velocity, that means that point will never try to move. Then the hinge reaction will be zero. Think of like this: if you're catching a stick or something, right? If that point where you're catching is trying to move, then only you will try to stop it, right? If it is not moving, then you'll not try to stop it only. Then the hinge reaction is zero. So indirectly, question became like this: since hinge reaction is zero, we can ignore the hinge. Then you can just draw the new free body diagram. Then it becomes your regular question, which you know how to do. So now we have a ball of mass m. This is going and hitting with speed u. After collision, this guy will get a speed of v1. The ball will get a speed of v2, and this will go with omega. Right? And we found out the topmost point, the hinge, is going with v1 backward and L by 2 omega backward. So this point should have velocity 0. So v1 minus L omega by 2 is equal to 0. Is that clear, everyone? The topmost point after the collision should have 0 velocity there. Right? Answer is very good, right, Arya? Then what to do here? We will take the point of collision. We will conserve angular momentum about A. You will actually get it in one step. Momentum कुछ नहीं करना था. L initial is equal to L final. So what is initial angular momentum? The ball angular momentum is 0. The final angular momentum ball ka is 0. For the rod, it will be mv1. What is this distance? This is x. And this is L by 2. So this distance will be mv1 x minus L by 2 minus k cap. And the rotation of the rod is ml square by 12 omega k cap. Take that v1 and substitute here. This will be m L omega by 2 x minus L by 2 is equal to m L square by 12 omega. L omega m will cancel. M L omega goes off, 2 also goes off. You get x minus L by 2 is equal to L by 6. We get x is equal to 2L by 3. And the best thing about this, independent of restitution, independent of mass of the rod, independent of mass of the ball. Did you see this thing? This thing doesn't depend on the type of collision, whether E is 0, E1, doesn't matter. It doesn't depend on how heavy the rod is or how heavy the ball is. If you can hit this rod at 2L by 3, the hinge reaction will be always 0. Is this clear, everyone? So the point of percussion for this rod is 2L by 3. Any doubts on this? Yeah, you can find V1, V2, but you don't need in this question. The question was that only find x where the collision, hinge reaction will be 0. So the idea is this: if you hit at this point, the hinge reaction ka, the point will have 0 velocity. So the hinge is not trying to move. Any doubts on this? Clear na everyone? Rudransh, clear with this? Samyak? Clear? Ovia? Arya? Anvita? Aditi? Advait? Devanshi? Clear with this? Clear? So that is there. One more problem on these rods. Then let's see one more. So we have a solid sphere. Mass m and radius r. Right? You gave an impulse here, j, at a height h above the center. What is an impulse? Think of like this: when you're playing snookers, you hit it with a stick, right? So that's an impulse basically. When you're playing carom board, you hit the striker. That's an impulse. You punch your friend. That's an impulse. So you just hit it, and you're just giving impulse j. And impulse j. When I wrote impulse now here, I think I did something wrong when I wrote the theory part. This part now, this is r cross j part. There is no integral there. Integral f dt will become j. An impulse j is given at a height h above the center. So people who are into that, that snookers and caroms, these people have to be very good at collisions. And maybe they don't know so much theory, but instinctively, right, they do understand. Find v and omega just after collision.
Sir, what is snookers?
है वो होता है ना, there's a table, there's a red ball, there's a white ball.
It's
क्या
also
बोलते हैं उसको? स्नूकर्स
billiard.
also called as what? Billiards.
Billiards.
Yeah.
हाँ, Both are different, yeah? Snookers and billiards.
No, it's the
No
same
idea.
thing, but more commonly it's known as billiard.
Yeah. Posh people call billiards and people like me call it snooker. So, aisa. So that just after collision, just after impulse. Right? Find H for pure rolling. The ground, even if it is rough, it doesn't matter because the friction will be non-impulsive. Let's get this. Let's see. So what's impulse basically? What is J? J is simply change in linear momentum. So in case you forgot, J will give you simply delta P mv final minus mv initial. What is angular momentum? Angular momentum delta L bar is simply R bar cross J bar, or you can simply take it as R perpendicular into J. This is your change in angular momentum. So whenever you hit something, right, you can give linear momentum and angular momentum. So yeah, so first step, what is that? Finally, what is the velocities? Let the velocity be v and let this be omega, and the frictional force is a non-impulse, so we can ignore because n is equal to mg and f is less than mu n. So this is a non-impulse, so we can ignore. And the collision happens so fast, the friction will not appreciably change anything.
Sir, can you explain this point again, please?
Which point? What did we say? If you have non-impulsive forces, they can be ignored for very small time dt.
Sir, how is
So
friction
friction is impulsive or
non-impulsive?
non-impulsive? Why it is impulsive according to you? Oh, bata. J is impulsive. You're hitting it, तो वो impulsive था. That is in which direction?
In the forward direction.
Horizontal direction.
Yes.
No, vertical direction में what forces are there?
Vertical
mg.
में N और mg.
mg is impulsive or non-impulsive?
Non-impulsive.
Then n will be what?
Non-impulsive. सर बट
Then f,
ऐसा भी तो
then
हो
f is
सकता
less
है
than
कि
mu n.
सर ऐसा हो नहीं सकता क्या कि फ्रिक्शन का कोफिशिएंट का वैल्यू बहुत बड़ा है एंड हमने मारा तो
What is the definition of
फ्रिक्शन
impulsive force?
बहुत बढ़
The
जाता
force
है.
should come to a large value in a short time. Doesn't matter. It's just a spike, isn't it? Mu कितना ले लोगे? Infinity.
ओके.
mu बहुत बड़ा ले infinity ले लोगे. So yeah, then what is the impulse there? So J is equal to change in momentum, simple mv direct. One step में आंसर आएगा. कुछ नहीं था उसमें. So angular momentum about center of mass will be the perpendicular distance from center of mass into J. The perpendicular distance from center of mass is h into J. That is equal to I omega. This is J into h is equal to I will be 2 by 5 mr square omega. There we get omega from here. 5jh by 2 mr square. Questions are not tough, but when they say impulse and doll, people actually get scared. बस ये हो गया. Then what is the second part of the question? For no slipping, v is equal to r omega. That will be J by M, and R omega will be 5JH by 2M R. H is equal to 2R by 5. Remember this question? If you apply force at 2R by 5, friction is always 0. हमने किया था ये रोलिंग मोशन में. This problem. Find the value of H, so that solid speed, same thing, sir. Check it out. This one. If H is equal to 2R by 5, the friction is 0. Means that point, if you hit it, right, what happens? An impulse will create a rotation and impulse also create a translation. And both of them will be created in exactly such an amount where V becomes equal to R omega. So at that point, no matter how hard you hit, the body will always start pure rolling. Clear with this? So basically, that is the point you want to hit even in that billiards, right? So that the ball won't lose any energy. If you hit above or below, the ball will actually start skidding when it moves. So what they do in the billiards, right? Let's say you want the ball to go front and come back. You must have seen such kind of trick shots, right? So if you want the ball to go back, go front and come back, what you want? You want velocity forward and omega backward, isn't it? Then where should hit? You should hit the point below, no? If you give an impulse here, then you're pushing the ball forward, but you're rotating the ball backward. So in billiards, if you hit the ball below the center of mass, the ball will go forward and then it'll come back. That is how they actually play the trick shots, right? You can even make the ball go, sideways also. Like, you can make the ball spin this way also. There, what they do, if this is the back view, you hit the ball little to the side here. If you hit here, then you know what you're doing? You're giving omega in this direction, isn't it? The ball is rotating this way, but it is going forward this way. The ball will have a different spin. It will actually start going that way. That's what you actually do in cricket also. In cricket, right, when you play, when you do this half spin and leg spin, what are you doing exactly? Ever thought about it? See, so if you're throwing an half spin or a leg spin, right, this is what you do. You give the ball a spin in this direction, omega, and you throw the ball forward. So when this ball hits the floor, this point will have a velocity r omega. So in order to stop slipping, friction will act this way. So this ball will fall like this and will go to the other side. So this ball will have a velocity on the other side. This is your half spin basically. So let's say this is the batsman, right? And you're throwing the ball with this kind of a spin omega. So the ball will go here. After hitting, because of friction, it will go like this. That's your half spin. If you rotate the omega this way and you throw the ball will go here, it will hit, friction will be that way, the ball will go this way. That's your leg spin. So depending on which way you're spinning the ball, left or right, if anyone is playing cricket, right, see, if you want to throw a ball half spin, what you do, you keep the ball here, you throw this way, isn't it? You throw this way. So you're giving the spin this way, and the ball hits the floor, it's skidding this way, so friction will act this way. You want to get a leg spin, you have to throw the ball this way. So if anyone plays cricket here and if you're a spinner, you will know that. You want a leg spin, you throw, your hand will rotate this way. Half spin, hand will rotate this way. So cricket mein normally what happens? Batsmen when they play, they don't actually look at the ball, they look at your hand. You're getting it? It'll be too late if you actually wait for the ball to say, especially in fast bowling, right? When people are throwing the ball, if you keep looking for the ball will vanish after some time, meaning the ball comes so fast you can't react. So what the batsman normally does, they look at the bowler ka hand, and based on that bowler ka hand and the point of release, they swing the bat. Meaning, think about this. What is the length of that pitch? Like, I think it's 20 yards or something, right? Almost 20 meters roughly. The ball is coming with a speed of 150, 160 kilometers per hour. So it takes the ball to cross the field almost, I think, 0.3, 0.4 seconds. A human ka reaction time, right? A very good sportsman will have a reaction time of around 0.5, 0.2 seconds. 0.2 seconds is the reaction time, meaning after seeing something, to react that there is something there, it will take 0.2 seconds for your brain to register. So if you wait for the ball to hit the ground and then bounce towards you, by the time you see the ball goes off already. It will be too late. So you have to swing your bat even before the ball lands on the ground. That is the reason swing bowling is so difficult to play. If you know what is swing bowling. The ball hits on the floor and then because of that spin, right, the ball ka, You guys see cricket, some of you, but you guys don't know something, no? What happens? You know why they bring fast bowlers in the beginning? And did you ever observe how the fast bowlers do the bowling? When you get a new ball, it is shiny on both the sides. These fast bowlers, you know what they do? They throw the ball in such a way it is always hitting the ground only on one side. They don't throw the ball however you want. When we play cricket, what we do, we throw the ball however you want, no? But both the fast bowlers, you know what they do? They hit the ground always with only one side. So what will happen? One side will become rough, one side will still remain smooth. So they do this for some 7, 8 overs. By then, this entire ball becomes pretty rough. They're actually messing up the ball structure. Now, when you throw the ball there, you know what happens? Because it became rough, there will be a lot of air drag on one side. This side, there will be less air drag. So as this ball starts going in the air, it starts wobbling in the air. The bowler himself does not know where the ball will go properly. Magnus effect. We'll see that later on. So this ball will actually start, wobbling. So now what happens when you throw the ball? The batsman will think ball is coming straight. But because of this air drag, which you don't know what is going to happen, the ball will actually bend in the middle of the air. But what did you do? You started swinging the bat thinking it is going to come in a straight line. But the ball actually takes a curve in the middle of the air. So the more rough it becomes really good for swing bowling. So during my time when I was in school, 10th standard and all, the world में one of the best, swing bowlers are Pakistani bowlers, Wasim Akram. That guy was one of the best swing bowler. One of the best spin bowler is Shane Warne, leg spinner from Australia. And these two people used to be get scared of only one batsman in the entire world, Sachin Tendulkar. He's the only guy who used to smash both of them right and left. Everyone used to be scared of, that Shane Warne, the leg spinner. That guy used to be deadly leg spinner. So Sachin is the only guy who used to beat them both right and left. So normally when Sachin plays the game and Muralidharan is a different story. So anyway, this is how the ball used to go. And then there's still an advantage. After 15, 20 overs, right, they bring the spinners. By now, what will happen? You got a very rough ball which spins really well. You will never give a spinner a smooth ball because it will start slipping in his hands. He won't get a grip. And that is the reason if the ground is having a fog or rainy, right, the ball starts slipping. Kabhi dekha, they keep rubbing the ball on the pant. They're trying to make it dry basically. It slips in the hand. So next time you see cricket, now you know why they do so many different things. And if you hit the ball out of the ground, kabhi observe kiya, they don't bring a new ball. The umpire will bring some 6, 7 old balls and they'll ask you which ball you want. They'll give you an option like, okay, which ball you want, because the bowlers have struggled for 10 overs to make that ball like that. And if you bring a fresh ball, the whole thing is messed up. That's a game ka strategy. Getting it? So that is the thing. So if you hit the ball out of the ground every time, the bowler will have to deal with a new ball. And Kabhi heard this thing, ball tampering? So this used to happen that time. Abhi nahi hota hai. So what these people used to do, some people used to put a coin in the pocket. They used to take the ball and they used to, mess up the ball ka structure. They used to remove some, piece. They used to make it more rough with a coin or something, without hitting the ground. It's called ball tampering, which is illegal though. I think nowadays you guys don't see all this stuff. I think 20 overs ka match, so no one cares. They'll just hit the ball right and left. So 50 overs mein the game goes in a long way. So that way. So getting it. So the ball goes left and right depending on how you spin. Then comes this guy called Muttai Muralidharan, Sri Lankan bowler, spin bowler, one of the greatest that time, right? This guy, right, during 2003 and all, right, Australians were the strongest players. I don't know who is now the strongest team. In 2003 World Cup, I was in 10th standard. Board exams chal raha tha, and World Cup was going on. Getting it? India won all the matches in World Cup except final. They won all the matches. They lost the final with Australia in 2003. Hopeless tha. I even didn't prepare for my 10th exam and I was watching this and they messed up the exam. It was so hopeless. Sandpaper. I think it happened in 2023 also, it seems.
Yes, sir.
So there. So anyway, so Australians used to be a really strong team, a really strong team. उस time तो literally everyone used to lose. Then they started playing with Sri Lanka, right? They used to beat every bowler, but this Muralidharan ka bowling, right? Literally, this guy used to go take 7 wickets, 8 wickets, and come. The only bowler the Australians used to be scared is Muralidharan. So what they do, what everyone does, they complain to this ICI boss. This guy is cheating. Now, when we can't play fair, what we do? We say you're cheating. So they Muralidharan, right? He bowls something called googly. If you ever heard about it, what googly means is when you throw your hand, it looks like an half spin, but the ball comes like a leg spin. You're getting it? And sometimes you try to throw an half spin, it comes like a leg spin. Leg spin you throw, it becomes an half spin. Sometimes you throw an half spin and half spin only comes. So it is really confusing. Matlab, we don't know what this guy is throwing actually. And which is actually kind of banned, which is not supposed to do something like that. These people complained to ICI and they stopped him from playing for 1 or 2 matches, which they won. And then obviously they took him for testing and they they checked his bowling action and everything. And what they found out, Muralidharan, right, actually has some 35% disability in one of his hand. That guy is actually physically handicapped, kind of. He's disabled. So whenever he throws the ball, the hand automatically rotates in a weird way because it is disabled, and the ball comes like that. So he's not doing it wantedly. It is not his fault. It is a deformity, which actually became his advantage. And so he was back into the game, and Australians lost the series. So that is how someone can use their weakness to, that guy made it an advantage. So that's a thing there. And we were so happy like Australians lost the series. So anyways, so bowling में बहुत होता है spin and all. So look at this. Let's see. One last one for rotation. Quotient restitution E. This is mu. So we have a ball here, solid sphere. Ball is coming with speed u and rotating with omega. It hits the floor. Find velocity and omega just after collision. Find the point where the ball lands on the ground after collision. This will be an advanced paragraph question. This you must have done. Did you ever play with this thing? You take a ball, you spin it like this, and you leave it on the floor. The ball hits the ground and comes towards you. You must have done this with a ball. You take a ball, you spin like this, leave it. It hits the floor and comes towards you. कभी देखा? So that's the same thing. You gave a ball with V and omega, it hits the floor, E and mu. So after collision, something happens. Find the velocity and omega after collision and the point where it lands on the ground. ठीक है एमेंडर. नहीं, नहीं आ रहा, इतना स्ट्रेट फॉरवर्ड नहीं है वो. When you hit the floor, friction on the ground is impulsive. And उसमें भी एक ट्रैप है. Let's see how you handle this. Step one, draw the final picture. Always, if you can't draw the final picture, then you don't know what you're, how you're going to start also. Biggest mistake. People, I don't know, for some reason, people don't like to draw pictures. So during collision, omega is this way. This is friction, which is impulsive now. This is N. That is also impulsive. Because during collision, N is impulsive, so F friction also becomes impulsive. After collision, this will be Vx and this will be Vy. Great. Now we know Vy will be nothing but E into U. That you remember, head-on collision, if you hit a wall with speed U, you'll bounce back with EU. That is fine. Right? Now, during this entire process, right, and wait, there is also omega also, Vx, Vy, and there is also an omega dash. So you can take this point A. If you see, just before collision and just after collision, torque about A is 0. All the forces are passing through this, so we can conserve angular momentum. So what is the initial angular momentum? This is point A. Angular momentum of center of mass, that is passing through A, that is 0. Angular momentum about center of mass, that will be ICOM omega. L initial is equal to L final. This will be 2 by 5 mr square omega minus k cap. L final, again, you're finding angular momentum about this point. Vy is going up, so we don't consider that. This will be mvxr minus k cap plus I omega, that will be 2 by 5 mr square omega dash minus k cap. Check. This is your conservation of angular momentum, everyone. You can conserve angular momentum about point A. K cap will cancel everywhere, M will cancel everywhere, one R also will cancel. You end up with 2 by 5 R omega is equal to Vx plus 2 by 5 R omega dash. This is equation 1. So I just need to find Vx and omega dash. My job's done. So yeah, I have one equation. I need one more. All clear with this? So you can conserve angular momentum about point A. So the second part, integral ndt, impulse problems. This will give you change in vertical momentum. Final momentum m into EU minus of m into minus u. So integral n dt will be mu1 plus e. horizontally. Integral f dt, the friction is the one who is responsible for the horizontal thing, mvx. So this will be mu into integral n dt is equal to mvx. But what is n dt? Mu into 1 plus c. We have done this kind of question. This is the third time you're seeing an impulse-based question. Remember where we saw this first time? In center of mass, bullet is hitting the block at an angle theta. ये problem, the second part. The bullet is hitting at an angle theta. This is the first time you saw an impulse problem. Then, where did you see? This problem, the second part. There's a rough surface again impulse problem. This is the third time you're encountering something similar. So Vx is equal to mu u1 plus e. I got Vx. Take this Vx and substitute in equation 1. I'll get this thing also. So this will be omega dash will be omega minus 5 Vx by 2 r. So you can substitute Vx there, you'll get omega dash also.
Sir,
Yeah.
sir, I think you should consider the velocity of that point A.
Q. A is a point on the ground.
I mean, the friction is acting on the point which is at the bottom, right?
So A
If
is
you
the
have to
bottommost
consider
point
that.
on the ground.
No, like at the bottom of the ball, the velocity will be omega
A
r.
is a point on the ground. Ground is not moving. A is not the point on the ball because that point is accelerating, non-inertial frame above. You're
Okay.
taking the point which is on the floor, which is in contact with the ball. So that point is moving. I agree. Ball में जो point है that is moving. I'm not taking that point. We're taking the point on the ground. So यहाँ पे देखो ना, where is the ball? There is no ball only, na? Just before touching. A is on the ground. Clear?
Yes,
Just
sir.
before and just after collision. All clear with this? The angular momentum and impulse. But the question is not over. There is a problem here. During collision, what will be the velocities? This is Vx and this is omega dash. Tell me one thing. Why is the friction acting in the first place? This is Vx and this is r omega dash. The friction is acting because when initially you're rotating, there is an r omega, but there is no velocity. So friction came and it is trying to decrease omega and increase Vx. So if Vx minus r omega dash is greater than equal to 0, then our answer is right. Then Vx is equal to this thing, whatever you got. Mu into u into 1 plus c. This is right. But let's say if you got after solving, this is after solving. Impulse problems may always, this is one big headache. After solving, if let's say Vx minus r omega dash is less than 0, what does it mean? Does it even make sense? Think about this thing. See, initially this point was trying to go backwards, so friction came forward. Okay? So friction is trying to decrease the speed, decrease the speed, decrease the speed. Eventually, it made the speed 0, meaning the slipping stopped. After the slipping stopped, do you think the friction will still continue to act? The moment the slipping stops, friction will suddenly become 0, right? You're getting the catch? So you cannot have Vx minus r omega less than 0. That means if you got Vx less than r omega dash, this implies we did something wrong. The slipping stopped during the middle of the problem. So the friction didn't act for the entire collision. The slipping stopped during collision. Therefore, F became 0 in the middle of the collision. We discussed this also. That means your equation becomes integral F max, friction is maximum only, but this will be dt dash. And integral n dt is mu1 plus c. So you can't solve this. But we did not solve this actually. Since the slipping stopped, we know Vx is r omega dash. So this is how the equations will be, which can't be solved. So therefore, Since the slipping stopped, therefore Vx must be equal to R omega dash. Are you clear with this? There, then you'll get your new Vx. And what is omega dash? Omega dash is omega minus 5 Vx by 2R. Substitute here, you'll get the answer. So there are two possibilities for an answer. If Vx is greater than R omega dash, this is the answer. If Vx is less than R omega dash, then this is the answer. Any doubts on this? And in case you're wondering, this is the exact same thing we did here. Remember, this is the whole story I taught you here. During the collision, if the velocity at the bottommost point becomes zero, friction will stop acting. I hope you guys remember this discussion which we did. You should check out here, page 199 in collisions. It is the same discussion. It's a good problem. Please definitely check it out. I still remember this thing. This thing, long back, I think 2010 or 11. I went to one of the institute. In the interview, they asked me this question in an exam. I did till here. I got this answer. I did everything right. And that option was there. I marked it. And then then that came wrong. I didn't understand why. When I checked it again, I realized Vx is actually less than R omega dash. Generally for students, we don't ask, but when you're taking an interview for a teacher, we ask all these kind of stuff. Question is not over. What is the B part? Then you're done almost. So after collision, this ball has a vertical component Vy, which is Eu, and you have a horizontal component Vx. This thing will fly like a projectile. Where the time of flight will depend on 2 vertical Vy by g. Range will be horizontal velocity into time of flight. This is the range. So this is where the ball will land on the floor. All clear with this? There. So you have everything. NLM, friction, circular motion, collisions, momentum, kinematics. Work per energy is missing, but yeah. Clear with this? There. With that, we are done with the chapter. 82 questions we have done. I think this is the second biggest one after kinematics. Almost 300 pages, right? Big one. Quite an important chapter. So please make sure to go through the entire notes. We are done with the chapter. You should start solving your material, right? When classes come material, whatever is there, start doing it, right? I'll also send you some sheets today on this. You can do that also. But again, priority, finish your material first. You can even do my booklet level 5 and level 6, which are pretty good questions. But again, finish your basic material first. Don't run behind between too many materials. If you ask me, I will suggest finish your classes come material, finish your HCV or DC band thoroughly, and then you can do more. Clear with this? Next thing, fluid mechanics. Now every chapter, right, will start feeling like something like mechanics only. You will be learning like 10-20% new, and remaining will be your NLM, friction, circular work, power, energy, and rotation. So, like I said, in the beginning, if you remember, I was telling you, right, physics, the chapters will keep going tougher, and then it will become normal. We reach the peak. Rotation is the peak there. Now, yeah, life won't become easy, but you'll get used to it. So, fluid mechanics. So first thing, when we keep saying fluid, let's define what is a fluid. Again, you'll be studying for ideal fluids. So any substance that cannot withstand tangential force. So there is a technical name for this. It's called shearing stress. We will see that later on in an elasticity chapter. For now, simply take it as a tangential force. What do you mean by this? So a liquid is a substance which cannot withstand a tangential force. So for example, let's say we have a pile of books. Okay, and let's say all surfaces are smooth. Now, if you try to apply force on these books, you will notice. Now, let's take all surfaces are rough basically. If you take all surfaces are rough, you will notice something like this. So if you're applying force F here, there'll be friction on this book, there'll be friction on this book, there'll be friction on this book, there'll be friction on this book. So all these things, right? There'll be some, friction between all these books and everything here. So friction here opposes the horizontal motion. So this is a pile of books. Hearing it, so friction opposes the relative motion. So if you see now, there is a resistance to the tangential force. If you try to apply horizontally, the books will not keep quiet. They will try to fight back a bit. So there is a resistance. So if you apply very little force, nothing moves. So they are resisting. They can withstand some force. But what if there is no friction between the books? Imagine the same thing. If friction is absent, right? And if you try to pull this, you will notice things like this. Meaning, if you apply force F here, that book goes that way. If you apply force here, this book goes this way. So you pull any book and every book starts coming out, isn't it? And no one is going to stop you from moving, right? If you pull the middle book will just come out. There is no resistance, nothing. In real life, you don't see this because there is a friction between books. So here, if you see, there is no opposition to the horizontal motion. So there's no opposition to the force parallel to the surface. This is the tangential force. Clear with this? So when you think about a fluid, right, even liquid behaves like this. A liquid is actually made of different layers. Clear? So think of this. When you put oil on a water, why does it float separately? You find like there are two different layers, isn't it? So same way, if you see fluid, right, it also has different layers. If you ever seen a lake when the water is flowing, right? Did you notice the bottom part, the water is flowing at a, slowly, at the upper part, the water is flowing at a different speed. So every layer has a different thing. So fluids have this property, if you take an ideal fluid, there is no friction between them. So every layer moves independently and, there is no, what you call, opposition to the horizontal force. So this is the main statement, everyone. Listen, this is the main concept there. So that means when you try to apply force to a liquid, it cannot withstand horizontal force. But if you apply force perpendicular, you're okay, isn't it? If you push the books from top, you're fine with that, isn't it? Books will simply get compressed. You can oppose that. So let me give an example. So let's say we have a container. Let's say we have some liquid. And let's say you're applying a force F at an angle. Somehow you're able to apply force F like this. This angle is theta. Now, if you resolve this force into two components, we get F cos theta and F sin theta. Just now we saw what will happen. F cos theta is compressing the liquid. I'm okay with that. But what does F sin theta do? F sin theta is pushing the liquid horizontally, and liquid cannot sustain. So the liquid will start going from left to right. Agreed? If you're pushing the liquid at an angle, because of the horizontal force, it will start pushing the liquid like this. Think of like this. If you can look at my screen, now see, if I take this, there. If you're looking at my book, right? Now, when I take this book and if I try to apply force horizontally, can you see how the layers are moving? Now, if I compress the book like this, there's no problem. I can compress the book how much ever I want, nothing happens. But the moment I try to apply the force horizontally here, you can see the book layers are moving like this. Can you see how they're gliding? This is what I was saying. A liquid, right? If you apply a horizontal force, the layers will not remain same. They will actually start gliding like this. Making sense? So, because of that, what will happen? The liquid layers will start moving from left to right here. And as the liquid layers start moving, the shape of the liquid will start changing. This will happen till when? This will keep on happening till there is no horizontal component. That means the force will become perpendicular to the surface. Is that making sense? Because if there is a horizontal component, the layers will move. But if the layers move, the shape of the surface will change. So this water from here is going here, na? So it is becoming more and more inclined. And this will keep on happening till the force becomes perpendicular. So here the F sine theta pushes the liquid to right, changing the shape of the liquid. Getting it? And this will happen, changing the shape of the surface till the force becomes perpendicular to the surface. You cannot have a horizontal component because the moment you have a horizontal component, the layers will start sliding. If the layer starts sliding, the surface shape will change. Is that making sense? And this will has to keep going on till it becomes perpendicular. Or you can say till the horizontal component becomes zero. If horizontal component is zero, means you're perpendicular to the surface. Are you getting the argument there? Till the force becomes perpendicular to the surface. There, we started the whole story with one statement. Fluid is a substance which cannot withstand tangential force. From there, we proved that means whenever you have a liquid, the force has to be perpendicular to the surface. So net force on a liquid surface is always perpendicular to the surface. And whenever you think, okay, why? Ask yourself, okay, if it is not perpendicular, there's a tangential force. If there's a tangential force, the shape will change. Therefore, it has to be perpendicular. Here, and just be careful here. How do you calculate net force? Whenever you calculate the net force, always calculate with respect to the container. That is, include the pseudo forces. If the container is accelerating, you have to include pseudo force with respect to container. So observer is always on top of the container. That is, include pseudo force if container accelerates. Is this thing clear, everyone? Shreyansh, clear with this? Rudransh, Vedika, Vanshika, Utsa, clear with this? Clear, Utsa? So let me give you some examples. If you take a container and just put liquid inside, what will be the shape? The liquid ka surface will be horizontal. Why? Because this is the surface. Gravity is acting down on the surface. That is the only force acting on the liquid surface, mg. Therefore, they have to be perpendicular. So if you just take a container and pour liquid, this is how you will see. What if you take a container on an incline? This is at rest. And if I put liquid inside, what do you think will be the shape? It will still remain horizontal, isn't it? Why? The only force acting on the liquid surface is mg. Makes sense. What if we have a container, this is theta, this is a smooth surface, and this time the container is accelerating with g sine theta. Now if you put liquid inside, what do you think will be the shape? What do you guys think? Remember what did I do? Draw the forces with respect to the right, Samir. So we have to draw the FBD of the liquid surface. Where is the observer? Observer will be on the container. And he himself is accelerating. So listen carefully. This is the incline. What are the forces acting on the liquid surface? We have mg sine theta and mg cos theta. Since you're in a non-inertial frame, we have to apply a pseudo force, which is mass of the liquid into acceleration backward. But I know acceleration is mg sine theta. That means mg sine theta will cancel there. That means the net force is perpendicular to the incline, only mg cos theta. That means the person on the container will think the net force is acting mg cos theta. So if you pour liquid into this container, the liquid surface will be parallel to the surface like this. And the net force on the liquid surface will be mg cos theta. Is that clear, everyone? You can even think, why that is happening in the ground frame. Listen, suppose if you take the container on a smooth surface, this is going with g sine theta. The liquid inside also is trying to go with g sine theta only, isn't it? Because everything is smooth. If both are trying to go with g sine theta, what will happen? Every time the liquid tries to come here, the container is also moving forward. But imagine if you keep the container at rest, then what will happen? Since the liquid is coming with g sine theta, it will start accumulating here and the surface becomes flat. Makes sense? Is everyone getting how to find the liquid surface ka thing? Any doubts on this page? We'll do more problems on this, but there, end of the day, the whole story of these 3 pages is this only. If you take an ideal fluid, right, no matter what you do, the net force acting on the surface must be always perpendicular to the surface. The net force must be calculated with respect to the container frame. Clear with this? Take a break. Come back in 5 minutes. We'll continue from here. Now we'll see some good problems on this. Any doubts so far? Chalo, come back in 5 minutes. So we have a container here placed on a rough surface. Mu is less than tan theta. That means this container is going to slide, but this time we have friction, right? It's not smooth. So find the angle alpha made by the liquid surface with the horizontal. There, I taught you only one concept till now. Huh? What is the concept? When you have a liquid surface, the net force acting on the liquid surface must be always perpendicular to the surface. And calculate the net force with respect to the container. Bus, that is the only concept I taught you. And you can ask some good questions on that. Let's see this thing. So I gave an example when the container surface was smooth, but now we have friction. Mu is less than tan theta. That means this is going to skid for sure. Find the angle made by the liquid surface with respect to the horizontal. Let's try this, everyone. Others, do keep your cams on. Tan alpha is sin theta minus. Hmm. नहीं रे सम्यक थोड़ा tan theta minus mu. हाँ, you got it ना? Simplify कर सकते हो. Just simplify that ना रे. You got it. Just simplify that ना. You just made it look so deadly. नहीं यार, yeah, that is wrong. I hope everyone else, the question is clear, Vanchika? Trishi, question is clear? Try. Why people are looking so tired and dull? Chalo, Vanchika, focus on the class. Let's get the question. Don't let your sister or siblings distract you. That is the job of the siblings. You should not get distracted. You guys still have good siblings. I think 2 years back, there used to be one kid. That guy used to come and beat the sister right and left. And he knows the sister can't do anything. So he used to come and beat her right and left from back. So one day I told her, next time when he comes now, you just turn back and you beat him. I'm fine with this. So he came like that only. He is a very small kid, Ray. Fifth or fourth standard, I guess. He's not smart. He then. So this girl was waiting. I was also waiting. When will he come? He came as expected. She switched off their camera and started beating him right and left. It was fun. Right, Samyak. Then, let's see now. Samyak, I'm little not sure exactly. That is the thing. Let's see. Sin A mu minus mu cos A. Okay, let's see. Maybe if you simplify, you'll get this answer only. So listen, everyone. So first thing, what will happen to the container? Now, if you just look at the container here, we know the container will accelerate with A is equal to G sine theta minus mu G cos theta. Hope you guys remember this from friction. The downward force is mg sine theta, upward force is mu mg cos theta. So mg cos theta minus mg sine theta minus mu mg cos theta is ma. In case you don't know that, I'll just write it down. Clear with this? This is friction, huh? Nothing new. Then what to do? Go and stand on the container and apply write the forces. So this is theta. What are the forces acting on this? This is mg sine theta. This is mg cos theta. Since you're standing on the container, we have to apply a pseudo force, which is ma backward, which is nothing but mg sine theta minus mu mg cos theta. That means, now look at this carefully. So this was the incline. The blue line is the incline. The net force will be mg cos theta. That is mg sine theta minus that. So this will be mu mg cos theta. The net force must be acting perpendicular to these two guys. So this is your F net. And remember, the surface will be perpendicular to F net. So the surface will be perpendicular to this green line. This is your surface. So that is what I want to find, which is alpha. And let this angle be, I will take this angle is beta. What is tan beta? Tan beta will be opposite side, mu mg cos theta by mg cos theta, which is mu. Right? If that is beta, this will be 90 minus beta, and this will be again beta. And this angle will be 180 minus theta. The sum of all those angles, alpha plus beta plus 180 minus theta, must be 180. So alpha will be theta minus beta. Theta is theta only, and beta will be tan inverse mu. Are you clear with this? It's just geometry after this. Huh? Once you got the net force, it is all geometry only. The only new thing you learned so far is this. Find the net force, and uska perpendicular line is the liquid surface. Is this making sense, everyone? And how do you find net force? We have done this in NLM. Samek, is this the same thing as what you got? I'm not sure. So
सर मैंने tan अल्फा इक्वल टू tan थीटा माइनस म्यू लिखा है, मतलब tan इनवर्स में
uh,
नहीं लिखा।
yeah. So, but you get the same thing, right?
यस सर।
Then ठीक है. आर्या चेक कर लो, मतलब did you get the same thing? H by L, A by G. What is H and what is L? I didn't give you anything here. If you take J effective, then we can do. But L and all I didn't give, no. But is this clear, everyone? Any doubts on this? Please ask me. Shaunak, clear with this? Obia, clear with this? Satyasha, Shaurya, Trishi, Shriyansh. Great. Clear, na, Advait? Like I said, there's only one concept you're learning here. Find the net force. Perpendicular to the net force must be the liquid surface. Done. After that is all geometry only. Let's see one more. So we have a cube here, which is an half-filled cube. This is L by 2. This is L. This is L. And this is L. The top is open, okay? This is an open top. So there's nothing on the top from spilling out. Then what you did, you started accelerating this container with A. Gravity is present. The container is accelerated horizontally with A. right? I want you to draw the shape of the liquid surface. How will the liquid surface be inside? And the amount of liquid spilled out. So since the top is open, if you accelerate really, really fast, liquid can spill out. Case 1, A is equal to G by root 3. Case 2, A is equal to G. Case 3, A is equal to G root 3. Three different questions, everyone. If the acceleration is G by root 3, find the shape of the liquid, how much liquid spilled out. If A is equal to G, shape of the liquid. A is equal to G root 3, shape of the liquid. If the liquid is not spilling out, then the answer is 0, no liquid spilled out. Let's get this. Hmm. Try. Everyone should try. I'll give a minute more, then I'll show you. Let's see. First, let's write a general formula, okay? It doesn't matter whether the liquid spills or doesn't spill or anything. If this is going with acceleration A, right, and if you keep an observer on this, what are the forces acting on the container? So if an observer is standing on the container and if he looks at the liquid and if you ask him what are the forces, he will say, okay, there is an mg and there's a pseudo force ma. So the net force must be perpendicular to this. This is your F net, right? So the liquid surface must be perpendicular to this. Right? And you can clearly see geometry there. This is MA, this is MG. If we take this angle to be theta, this angle to be theta, this is F net, that is theta, so this is theta. Tan theta will be equal to MA by MG. Tan theta is A by G. Do remember this result. Quite useful. It doesn't matter what is the shape of the container. You take any shape of the container, tan theta will be equal to A by G. Later on, we will see G effective and all that stuff. But yeah, that is the main idea there. So case 1, A is equal to G by root 3. So tan theta will be 1 by root 3, 30 degrees. So the shape of the liquid will be something like this. And this makes 30 degrees. There is no spill. There is no spillage. Case 2, when A is equal to G, theta is 45. Now you're just about to spill. Now the liquid will be exactly on the edge because it is a cube. Clear with the shapes? The next one will be interesting. How will 60 degrees look like? Because this is already 45. Case 3, if A is G root 3, we should get theta is 60. Now in this thing, theta 60, you cannot increase the height. You cannot have a liquid like this. Doesn't make sense. So the only way you can have 60 degrees is you change the base. So this height is fixed, L. The base becomes L by root 3. Basically, the liquid ka shape only will change. Like, this part will get exposed. It looks like this. It's like a trapezium. Are you guys able to visualize? This part of this thing, there'll be no liquid here. That part will get exposed to atmosphere. You're accelerating so fast, that part will get literally, there'll be no water there. All this liquid will be here in this trapezium shape, the triangular shape. And this angle will be 60 degrees. Is that making sense? The formula is still valid. You have to make 60 degrees, but you cannot increase the height, right? Every time the water tries to go up, that will start spilling out. So if you can't change the height, then change the base. So what is the final volume? Half, base, height, and width. This width is also L. Initial volume L cube by 2 because it is half filled. Therefore, volume spilled, subtract them. Check. Right, Arya. All clear with this? Again, what did we do exactly? We just did pseudo force and all. This is all NLM. There's nothing new there. If you stand on the container, there is a pseudo force, find the resultant force and draw a line perpendicular to it. That is the surface. Any doubts on this? Right, Arya. All clear with this, Advai? Rudransh? Anvita? Clear? Next one. So that's a decent question. This third one will be a pretty good advanced question. Let's say we have a cylinder filled with liquid. Let this be H. Let the total height be capital H. And let the radius be R. Then what you did, you started spinning this container. You started spinning the liquid basically with omega. So normally, right, the liquid will have a slight friction or something. Somehow you're rotating it. So once you start rotating, this liquid ka shape will change. You must have seen this. Ever seen a bucket of water or a glass of water with a spoon when you spin? The liquid actually forms a bowl kind of shape. This height becomes H2. This height becomes H1. So the lower part of that and this thing is H1 and H2. And this is your radius R. So first thing, find the equation of the curve. So this is the liquid curve. Find the equation of the curve and find H1, H2. Assume there is no spillage. In case you're wondering what is this, if we did this in basic calculus, yeah, the equation. Paraboloid. When you have a water rotating in a bowl, the shape you get is a paraboloid. This is where we have discussed this first time. First, let's get the equation. If I just ask you equation of the curve, it's a decent main level question. The moment I ask you H1, H2, it becomes a good advanced question. Again, more of a maths than actually thinking. But let's see. Everyone should try. It's a good one. Just give it a try. Get some water on top. Hmm. I want H1, H2 separately. Right? What you got is not wrong, but okay. That looks right, Arya. Hmm. If you guys actually remember the results of the paraboloid, it gets over very fast. Do you guys remember paraboloid ka definition? That thing? When we proved this, I taught you something. Paraboloid is a property. The volume of the paraboloid is half of the volume of the cylinder enclosed. Yes. अभी याद आया कुछ? You need to know that result, or else you have to integrate. मतलब not a big deal, but yeah. So how do we do this? Yeah, let's see the equation first. I think that you should have got it right, Obia. And most of you did get the equation right. Right, Anvita. So first, let's see the equation part. So if you take this point as x comma y, let's take this as origin, this thing as x comma y. So this particle here is going in a circle. So this experiences a weight dmg. Take a small mass dm. The centrifugal force dm omega square x, that is the radius. So the net force will be in this direction. That's your F net on that surface. That must be tangential to this surface. So if this is angle theta, this is theta, this is theta. So from there we get tan theta will be dm omega square x by dmg. But I know tan theta is nothing but dy by dx, which is omega square x by g. Integrate on both sides. We get y is equal to omega square x square by 2g. That is the equation of the curve. It's a paraboloid in 3D. It's a parabola. Pretty decent result. Proper mains level question.
Sir, I think we need to convert it into the heights given from the base.
देखते हैं ना. This is just I'm finding the equation, right? All clear with this.
Okay.
This is the first part. We got the equation. Then now you can split this whole stuff into two parts. This can be split into this paraboloid. Remember, liquid is in this region. Plus this one cylinder solid. Now it is given in the equation that is H2 and H1. So this height will be H2 minus H1. And this will be R. This height will be H1 and this will be R. So this volume will be pi R square H1. And this volume will be half of that volume of the cylinder, which is half into pi R square H2 minus H1. Is that clear, everyone? And where did we get this from? This you should check out in basic calculus, page 133. So what we are doing is basically conservation of volume. What was the initial volume? Pi R square small h. Initial volume is pi R square small h. This must be equal to pi R square by 2 H2 minus H1 plus pi R square H1. Pi R square will cancel everywhere. We get H is equal to H1 plus H2 by 2. It's a pretty good result to remember. This is your equation 1. Clear with this? Equation 2 we can say. And from the previous equation, now you can clearly see so this coordinate will be how much? This is R and this is H2 minus H1. So if I substitute here, we'll get H2 minus H1 is equal to omega square R square by 2G. This is one equation. So this will give you one equation between H2, H1, and this will give you one equation from the conservation of volume. This is a volume conservation. Because the liquid didn't spill out, you can conserve the volume. And this thing came from the equation. All clear with this? Equation 1, equation 2, solve them. H2 minus H1 is omega square R square by 2G. H2 plus H1 is equal to 2H. Done. Two equations, two unknowns. Add them up. We will get H2 is equal to H plus omega square R square by 4G. H1 will be H minus omega square R square by 4G. There. Now they can ask questions like this. if you want the liquid to spill out. If you want the liquid to spill out, then the height h2 must exceed the capital H, isn't it? If h2 is exceeding capital H, what will happen? Liquid will spill out. So questions will be like this. Find the angular velocity so that the liquid will spill out. So then this will be h plus omega square r square by 4g must be greater than h. So we get omega will be 4g by r square h minus small h ka root. If you spin anything more than this, the liquid will spill out. Clear with this? There's another way of asking. What is the omega if the bottom part is exposed? You're rotating the liquid so fast, the bottom container part, you can start seeing it. A bottom to be exposed, meaning it would become like this. Then h1 must become 0. h1 is less than equal to 0. H minus omega square rg by less than 0. So this would be omega must be greater than equal to root over 4g h by r square. Meaning the shape would look like this. The liquid is rotating so fast. It's kind of like this. You're getting? Meaning if you had extended this, the parabola would have been gone further down. So this part gets exposed here. Making sense? That means basically you took h2 as h1 as negative, which doesn't make sense. Are you clear what is happening? So if you rotate the liquid really fast, the bottom part of the bucket you can see. So they can play around like this. Clear? That's what makes this question really good. You can put a matrix matching on this. For different omegas, you can see liquid spilling out. For another omega, the bottom part is exposed. So you can play around like that. All clear with this? And what did I teach you till now? I taught you only one statement till now. For an ideal fluid, the net force acting on the surface must be perpendicular. That's it. We just learned that one. That we did 3 questions on this. All clear with this? So technically speaking, it is still kind of NLM only. We didn't do anything new. Fluid mechanics is, when you look at fluid mechanics, right, you will see a lot of NLM. Great. Let's go ahead. Let's define now a little more things. Like first thing is density. So if you remember in NLM, when we studied, right, the two important properties we always studied in laws of motion, one was force and one was mass, isn't it? F is equal to ma. You are more interested in the force and the mass. Just give me a minute. I'm just kicking people out. There, I kicked 4 people out. Great. So when you studied NLM, right, if you see, we are more focused on force acting on the body and mass of the body. But now, when you study about liquids, right, force and mass really don't make much sense. So when you study for liquids, we prefer to study density and we prefer to study pressure. Why density makes more sense? Think about it. 10 liters of water, 1 liter of water. What remains same? Density. Mass will depend on the container ka volume, but density does not depend. Same way, pressure is a better quantity than force. So when you study liquids or fluids, we prefer to study in terms of density and pressure. So basic definition, what is density? Rho is mass by volume. Right? And there are certain things you should remember. Density of water, 1 gram per cc or 1000 kg per meter cube. Density of ice, 0.9 gram per cc, 900 kg per meter cube. Density of mercury, These are standard things which keep coming, so better you remember. 13.6 gram per cc, 13,600 kg per meter cube. So if you actually jump into the mercury, there is no way you will drown. You will get mercury poisoning and die, but you will not drown. Anyway, mercury is not good. This Chinese emperor is right. They used to think mercury is an elixir. They think the god is right. Mercury is a kind of an elixir, and the Chinese guy, the doctors or whatever the physicians, they used to give the king mercury-filled stuff. And most of the kings, now they used to die even before in engage only because of mercury poisoning. But they used to eat all this stuff thinking of immortality. And these kings who lived also, na, they used to believe in this mercury, and they found one of the tomb. Okay, it is the filled with mercury ka pool. It's a swimming pool filled with mercury, and in the middle there is an emperor ka dead body. And mercury doesn't get spoiled. That is one of the largest reservoir of mercury they ever found. Actually, they must have drained it and sold it off. So, but yeah. Anyways, mercury is something like that. Then we have few terminologies here. This is the few words you keep hearing. Okay, specific gravity. You should know your terms. So specific gravity is nothing but relative density with respect to water. Example, if someone tells you specific gravity of gold is 19.3. The meaning of this is density of gold is 19.3 times density of water. Which is 19.3 gram per cc. 19,300 kg per meter cube. Right? So that is one. And they sometimes use relative density, that is straightforward. Now, variation of density with temperature. Now, this we will do in thermodynamics, but you can just remember the formula for now. If you increase the temperature, body expands and then the density will change. There is something called anomalous expansion. That also we'll see in thermal expansion. For now, we'll not get into it. So density of the liquid, the new density, will be rho old density pi 1 plus gamma delta T. There is a formula like this. We'll do this in more detail in thermal expansion. Gamma is called coefficient of volume expansion. So generally, when you heat up a liquid, the density drops. Yeah, have a look at this. All clear with this? Let's see a question. We have two liquids. Of density rho 1 and rho 2 are mixed. Case 1, you mixed equal volumes, meaning you took 1 liter of rho 1, 1 liter of rho 2. Case 2, equal masses, 1 kg of rho 1 and 1 kg of rho 2. Assuming the liquids don't react or anything, find the average density. If equal volumes of rho 1 and rho 2 are mixed, find average density. If equal mass of rho 1 rho 2 are mixed, find the average density. Get this easy one. CET level question. Done. This is an easy one. Right, Samya. Right, Ishman. That is right. Yeah, right. See, what is the first one? What is average density? Rho average is total mass by total volume. So you have said equal volumes. So rho 1 into V plus rho 2 into V by volume is V plus V. You know, how is this like? This is like the kinematics problem. A vehicle is going with speed V1 for time T1 and speed V2 for time D to find average speed. A vehicle goes with half the distance with speed V1 and remaining half with V to find the average speed. So here, now it is a total mass. So M plus M, volume will be mass by density. Isn't it? This will be rho 1, rho 2 by 2 rho 1, rho 2 by rho 1 plus rho 2. Check. Clear with this thing. That's a little about density. So next thing would be on pressure. I think we will start off that fresh in the next class. So next class when we catch up, we'll continue from here. We're going to start with pressure and we will do all pressure-based problems, right? So that is there. Okay, with that we'll wrap up for the day. And do remember there's a test online till tomorrow, so make sure to give. So I'll see you guys again next week on Tuesday, same time. So any doubts, anything else, please stay back and ask. Also, feel free to leave.